asking you which of those things is going to be an element, which is going to be a compound. Or we will give you a formula of a chemical, and we'll ask you whether this is a pure substance or it's a mixture. And you have to know these definitions there. Okay? Now molecules there, and again, consists of two or more atoms of the same or different elements. So this is a situation where we call an oxygen molecule. Same atoms, two oxygen atoms chemically bound together. This is a situation where you have two different types of molecules, two different types of atoms combined together. Okay? They have to be bounded together. It's not like sand and water. You mix them together, sand is sand, water is water. Okay? And they're not chemically bounded together. And so the molecule, by definition, has to have at least two. You can have more, same or different types of elements chemically bounded together. Okay? So that's how we define molecule. And again, that's a D word. That's something that you need to remember how we define. You will be asked this kind of questions related to the definition here in your homework assignment, in the quizzes, as well as in the upcoming exams there. So examples of molecules, we can have water, H2O, glucose, carbon-6, hydrogen-12, oxygen-6, okay? Ammonia, NH3, chlorine gas, oxygen gas, hydrogen gas, and bromine gas. And bromine is a liquid there, actually. So you can see these are the examples of molecules there. We have either the same type of atoms chemically bounded together, or we have different types of atoms chemically bounded together. They stay together as a fixed unit there. Okay? If you have O2 versus O3, O2 is oxygen gas, O3 is ozone. Okay? When you change the composition there, you change the identity of the compound there. Okay? So the formula of the compounds are very important. You see in the examples that I showed here, you see the subscript numbers. H2O, that means in that molecule you have two hydrogens, you have one oxygen in there. Okay? Now, in this particular example, the uracil, one of the fundamental components of RNA, you see carbon 4, hydrogen 4, nitrogen 2, oxygen 2. Okay? Now, the colored subscript in red indicates the number of atoms. If you can take one molecule out, that means one uracil molecule will have 4 carbons in there. Okay? And you will have 4 hydrogens in there. 2 nitrogen atoms and 2 oxygen atoms. Okay? So the formula of a compound is very important. And you have to be able to recognize the compound by its formula. Now when you work with different types of compounds there over and over, you will memorize their formula. And we will ask you to give names for a particular formula. And given the names for a particular formula, we will ask you to write out their names. And then for a particular name, we need you to be able to write out the formula. So this is very important there. So the structure-wise, if you have the uracil there, and you can see these are the 4 carbons there. You have the white balls representing the hydrogen, and then you have the blue balls representing the nitrogen, the red balls representing oxygen. So this is a formula of the compound. This is what we call a structural formula. The structural formula actually gives you the actual connections among the different atoms, how they're connected to one another. Now, when you look at that C4, H4, N2, O2, you don't really know who's connecting with whom. But in this case, we can see carbon is connected, carbon, hydrogen, carbon, hydrogen, carbon. Okay? So the structural formula is another way to represent chemical compounds. And we will get into, when we talk about the formula, different types of formula that we use to represent a compound here. We'll give you more examples. Okay? And so many compounds are made up of molecules, but not all molecules are compounds. Elements can actually exist in molecular form. These are the elements that will exist in molecular form. Hydrogen do not exist by itself. Hydrogen combines with another hydrogen atom. So hydrogen molecule, H2. Hydrogen gas is a molecule. Nitrogen, N2. Oxygen, you have 2 possibilities there. You can have 2 oxygen atoms connected together. You can have 3 oxygens connected. 3 oxygen atoms connected together. One is regular oxygen gas, the other is ozone. And then this is what we call the group 7A elements in the periodic table. We'll get into the periodic table a little later in this chapter there, they are all diatomic molecules. That's a new term that we use. Diatomic meaning you have two atoms combined together. Okay, diatomic molecules, and this will be a triatomic molecule, O3. Okay, so all those mono represent single, di represent two, and tri represents three, and so on and so forth. Okay, so molecules can actually exist. The elements that can actually exist as molecules. So when you use the term molecule, do not automatically think it's going to be a compound. Yeah. These are two different types of molecules. One is a pure element, the other is a compound. So there's a difference between molecules and compounds. Okay? And decomposition of water. We say compound can be separated into smaller, simpler molecules there. And this is an example there. If you have a cup of water there, and you have a battery and two electrodes there, and when you put those two electrodes in the water, separate them, and you put a test tube on top of each electrode there, over time, as the electricity going through that liquid, you are going to be able to do decomposing H2O back into H2 and O2. One interesting thing though is that you will notice the volume ratio between oxygen gas and hydrogen gas is that hydrogen gas volume will be twice as much as the oxygen gas volume. 2-to-1 ratio. 2-to-1 ratio. Okay, so we can actually decompose a compound into simpler, smaller molecules or atoms for some time, in some situations there. And water is a perfect example. So that gives you an example of difference between a compound and an element. Okay? And so that's for the pure substance here. We have elements, we have compounds there. Now the classification for the mixture there, we have two different types of mixtures, okay? And heterogeneous mixture and homogeneous mixture. Now this categorization of mixture depends on how uniformly the substance within them mix with one another. We say air is a homogeneous mixture because in the air we have oxygen gas, we have nitrogen gas, we have carbon dioxide, water vapor, pollutants in the gas phase, carbon monoxide and nitrogen monoxide, and so on and so forth. You can't really tell which part is which. Okay? So it has a uniform composition there, and we call it homogeneous mixture. And heterogeneous mixture is another example there. And we have different, in the mixture there, we will be able to see different phases there, solid, gas, and liquid. Okay? So for the heterogeneous mixture, it is the one in which the composition varies from one region of the mixture to another. So it's made up, we know mixtures are made up of different types of substance, mix them together there. Okay. So salt and sand, you mix them together. Salt is salt, sand is sand. They're different. Okay. And so the portions of the sample of the heterogeneous mixture will have different composition and properties. Okay. So if you take salt and sand and mix them together, and if you take part of that mixture out, you may have more sand than salt in one portion of the mixture there, and another portion you may have more of the other components in there. Okay, so here a heterogeneous mixture refers to the composition, the different composition in the mixture.